You are listening to The Vocal Technologist. Spoken tech for your ears.
Okay, if you're like us, trying to keep track of all the security news lately, wow, it feels almost impossible sometimes.
It really does. 1 minute it's your phone's core image processing, the next it's, your main developer
But
tool.
the pace is just relentless.
Yeah.
So that's why we wanted to put together this strategic briefing for you. We've waded through the recent attacks, tried to filter things down.
Go through the headlines, basically.
Exactly. Pull out the key facts, the trends you really need to know about what's happening right now in the cyber landscape. Think of it as your quick update.
Right. And our goal today is really to show how the attackers, from the big state groups down to, organized crime, how they're innovating. We're going to touch on everything from like those deep OS framework exploits to weaponizing everyday apps, things you use constantly.
And looking across all the material, one thing really stood out, didn't it? This focus on really fundamental components.
Oh, definitely.
Why are we seeing such a spike in 0 days hitting core OS infrastructure? What's going on there?
Well, what's really fascinating, I think, is how foundational these bugs are. So we're not talking about some niche business app anymore.
No.
We're talking the basic ways your phone or computer handles data, like images. Stuff that just has to run. You can't just switch it off.
Let's take Apple as a prime example. That critical 0-day CVE 2025 43300 in the ImageIO framework.
Yeah.
How did that one actually work? Break it down for us.
Yeah, that one was nasty. It was an out of bounds, right? So basically a memory corruption issue.
Okay.
When the device tried to process a specially crafted image file, maybe one you just got in a message, right? It could write data outside of its allowed memory space.
Allowing an attacker to mess with the device's memory.
Exactly. And it was used in some very sophisticated targeted attacks against specific people, high-value targets.
And the big picture takeaway isn't just the patch itself, it's the sheer number.
Oh, absolutely. That was Apple's 7th actively exploited 0-day patched in 2025 alone.
Yeah.
7th.
Wow.
And they had to push patches for iOS, iPadOS, macOS, even older devices that normally wouldn't get updates.
Why? Because ImageIO is just that fundamental.
Precisely. You can't disable it. It's essential. So attackers know hitting these core, long-standing components gives them huge reach. It's a persistent target.
And this mobile threat, it's not just an Apple problem, is it? We saw something similar with Samsung devices, too.
No, definitely not unique. There was that remote code execution flaw in Samsung's libimagecodec.quorum.so library affected Android 13 and up.
Same kind of area, image processing.
Exactly. That just highlights how fragile this stuff is across the whole mobile world. And interestingly, that Samsung bug was reported by researchers from WhatsApp and Meta.
Shows you how seriously the big players are taking these foundational flaws. They have to.
They really do.
Okay, so sticking with this theme of low-level access, let's talk about the kernel, that Eternal-Tux Linux RCE exploit against ksmbd. That wasn't even a new bug, was it?
Well, yes and no. The interesting thing there was the method. It was an authenticated zero-click RCE, but they achieved it by chaining two older, already known end-day vulnerabilities.
So flaws that had patches available.
Right. They basically glued together CVE 2023 52440 and CVE 2023 4130 to get remote code execution, even bypassing modern kernel protections.
Creating a sort of new 0-day from old parts.
You got it.
Yeah.
Shows how attackers are getting smarter about combining existing weaknesses.
And that level of compromised kernel access, messing with core OS memory that leads to, well, huge problems for organizations. Let's look at the real-world impact.
Yeah, it can be devastating. Look at the financial sector. The Logic card breach over in Korea. Over 1 million users confirmed impacted maybe several million out of their 9 million customers.
And that wasn't just names and emails, right?
No. Card information, online payment details, really sensitive stuff.
And that kind of thing is often an external attack. But sometimes the threat's already inside. That FinWise bank incident, that's the insider threat nightmare.
Oh, absolutely. FinWise blamed an insider for a breach affecting nearly 700,000 customers. But the really scary part,
the timeline.
They detected the breach over a year after the data was first accessed or stolen. A whole year.
Wow. That points to some serious blind spots in monitoring, doesn't it? Especially for privileged users.
Totally. If major incidents are going unnoticed for 12 months, that's a fundamental detection problem, not just a one-off mistake.
Okay, let's shift gears a bit. We've talked OS components. Now let's talk about the software supply chain. The developer ecosystem seems incredibly fragile right now.
It's a massive target.
Yeah.
Huge. Think about it. If you compromise a tool that thousands of developers use.
You hit potentially thousands of companies at once.
Exactly. And we saw that clearly with that big npm supply chain attack. Malicious code got injected into, what, over 40 packages.
And the code itself, it wasn't just generic malware, was it? It was very specific.
Incredibly specific. Targeted credential harvesting. The malware, hidden in a bundle.js file, used the truffle hog scanner.
To do what?
To actively hunt for secrets on developer machines. Things like GitHub tokens, AWS keys, npm tokens, the very keys developers use to access critical systems.
And the really sneaky part, it didn't just infect and run once, right? It set up persistence.
Yeah, that's the worm-like aspect. It created persistent GitHub Actions workflows.
Meaning,
even if you clean the malware off your local machine, it had already set up shop in your CI/CD pipeline to keep stealing secrets from the build process itself. Long-term access. That smells like espionage.
And often, the way these attackers get in is surprisingly simple. There was that other huge NPM compromise before this one, affecting packages downloaded billions of times weekly.
And that started with basic phishing. A maintainer got a fake email pretending to be NPM support, asking them to update their 2FA.
And they just handed over access.
Pretty much.
Yeah.
And, the initial reaction from some in security was, oh, minimal impact, maybe some crypto stolen.
Yeah, we can't just accept that narrative, can we?
No way. Millions of people downloaded those compromised packages. A package takeover needs to be treated with the same urgency as a 0-day. The potential blast radius, the cleanup effort, it's enormous.
It wasn't just package managers either. We saw the WhiteCobra campaign flooding the VSCode marketplace with bad extensions.
Right. And one poor Ethereum developer lost their wallet from an extension that looked totally legit, had like 54,000 downloads.
People trust those download numbers, the professional look.
They do. It highlights how much we rely on marketplace metrics as a proxy for safety. But, thankfully, the ecosystem is starting to react. We're seeing mitigations, like what pnpm is doing with version 10.
How is pnpm changing things? What are they doing?
Two key things. First, they're disabling the automatic running of postinstall scripts by default. That's where a lot of this malware hides.
Okay, good step.
And second, they introduced a setting called minimum release age. Basically, it adds a delay before you can install a newly published package version.
Giving time for security checks.
Exactly. Gives the community and automated scanners time to flag something suspicious before it gets widely installed. It's a really smart architectural shift towards caution.
Okay, let's switch tracks again. We've covered exploits, supply chain. Now, how are attackers hiding? We're seeing them use everyday tools for command and control C2 traffic, like Discord and Slack.
Yeah, tools like CRN and CR2 are proofs of concept showing this. They package up the C2 communication and funnel it through platforms like Discord or Slack.
So it just looks like normal encrypted chat traffic.
Pretty much. It blends right in with all the legitimate encrypted traffic that's already on most corporate networks. Standard network monitoring tools often just see expected noise. It's clever evasion.
But just a warning there, right? Slack and Discord themselves might still be able to see that traffic.
Potentially, yes.
Yeah.
It's encrypted and the point, but the platform provider might have visibility depending on implementation. Still, it bypasses typical perimeter defenses.
And when hiding C2 isn't enough, they're getting incredibly good at the initial phish, like this void proxy platform, phishing as a service.
Void proxy is scary stuff. It uses adversary in the middle techniques. So you visit a fake login page.
Okay.
You enter your username, password, even your MFA code. Void proxy intercepts all of it in real time, uses it to grab your valid session cookie, and logs in as you.
Bypassing MFA completely.
Bypassing MFA completely. But the real genius, or the really devious part, is how they get past spam filters.
How?
They don't use throwaway email addresses. They use compromised accounts from legitimate email service providers, like Constant Contact.
Ah, so the phishing email looks like it's coming from a trusted source.
Exactly. It sails right through spam filters because it originates from a known, reputable sender. Hard to block that.
Now, here's where things get really, really interesting for me. Using old legacy components to bypass modern security. That technique for dumping LSAS memory on Windows 11?
Oh yeah, that's a classic low-level trick. They found this vulnerable, older version of WorfaultSecure.exe.
The error reporting tool.
Right, but specifically a version from Windows 8.1. And the key is that old version runs with the highest protected process light, or PPL level.
Meaning it's highly trusted by the OS.
Super trusted. It has permissions to access protected memory spaces, like the LSAS process memory where credentials live, that modern lockdown processes can't touch.
So use the old trusted tool to grab the goods, but then how do they hide the file with the dumped credentials?
They disguise it. They dump the memory, then they slap PNG image file headers onto the beginning of the data.
Making it look like a picture file.
Yep. Designed specifically to fool antivirus and EDR tools that scan for malicious file types or signatures. Very sneaky.
This whole trend of going lower and lower down the stack, it really brings us to that raw disk parser script.
That script is a perfect illustration. It's a Python proof of concept that reads file data by parsing the NTFS file system structures directly from the raw disk.
Bypassing the normal Windows file system calls entirely.
Completely. It doesn't use the standard Windows APIs to open or read files, which means most security monitoring tools, which hook into those high-level APIs, are completely blind to it.
Fundamentally bypassing a whole layer of defense.
Exactly.
And this level of sophistication, it's not just random criminals anymore. It connects directly to state actors, espionage, like the Chinese group TA-415.
Right. TA-415 was caught using VSCode's remote tunnels feature.
A legitimate developer tool for collaboration.
Yep. They were using it to spy on U.S. economic policy experts after tricking them with fake emails, turning a productivity feature into an espionage backdoor by abusing trust in the dev community.
And now, even the social engineering side is getting an AI boost. North Korea's Kimsuki group using deepfakes.
Yeah, this was pretty wild. Kimsuki was using AI-generated fake military ID cards. These fakes were assessed as being like 98% likely to be deepfakes.
Targeting South Korean defense personnel?
It shows a shift from easily spotted, clumsy phishing attempts to using readily available AI tools to create really convincing fakes designed to fool people, at least initially.
But maybe the most unsettling AI vulnerability is this shadow leak thing in ChatGPT. It's not like the prompt injections we usually see.
No, it's indirect prompt injection. The malicious instruction isn't in the chat window you see. It's hidden somewhere else the AI has access to.
Like where? An email?
Could be. Maybe hidden in the metadata of a calendar invite or buried in an email signature. Then later the user asks ChatGPT a totally normal question, like what's on my schedule today?
Okay.
The hidden instruction triggers. The AI is manipulated into searching the user's email, finding sensitive data, maybe contacts, maybe financial info, encoding it, often in base 64.
Disguise it.
Right.
Yep.
And then it exfiltrates that encoded data directly through OpenAI's backend servers.
Yeah.
Not through the user's browser.
And because that whole process, the search, encode, exfiltrate, happens on the back end, it's basically invisible to the user.
That's why they call it nearly impossible to detect. It's a fundamental bypass.
Yeah.
A huge security challenge we need to get our heads around fast. This is the kind of thing we try to keep an eye on here at the Vocal Technologist.
Okay, so wrapping this up, what's the big picture here? What does this all mean for, for you listening?
I think the current challenge is really two-sided. First, you've got to manage these massive supply chain risks, npm, VSCode, developer tools being hit hard for persistence. And second, we're dealing with unprecedented levels of stealth. C2 hiding in Slack, data theft happening silently through AI backends. The traditional security perimeter.
Right.
It's effectively gone. Attackers are bypassing internal systems by design now.
And just as a strange closing note, we saw reports that some of the really big, notorious cybercrime groups, Scattered Spider, Lapsus, Shiny Hunters, they all announced they were going dark.
Yeah, posted farewell messages on breach forums claiming they'd achieved their goals or whatever.
Kind of weird timing.
Very weird.
So the final thought maybe to leave you with is this. In a world where AI can silently steal data via your cloud chat tools and state actors use your dev tools for spying, is this retirement by the big gangs just, a rebranding?
Or are they just shifting to even stealthier, less attributable methods?
Something to think about as you look at your own defenses this week. Thanks for tuning in for this briefing.
Spoken Tech for your ears.